In this video, we're going to find the absolute extrema, and we have a polynomial on a closed interval. All right, when you're finding absolute extrema, so an absolute max or min, the plan of attack is to find the critical numbers, check to make sure that they're in our interval, and then we're going to evaluate f at our critical numbers. I'm just going to put C in for critical numbers, and the endpoints of our interval. Okay, so that's our plan. Okay, in a previous video, we found the critical numbers for this function. The critical numbers, when we took the derivative, set it equal to 0 and solved it, was positive 2 and negative 2. We got two answers. Okay, so what this means is that we are going to go ahead and we're going to plug in positive 2 and negative 2 along with negative 3 and 4 into this function. Okay, so first up is f of 2. So I'm going to take 2 times 2 cubed minus 24 times 2. And if we do this arithmetic, we're going to get a negative 32. All right, we're going to repeat it. F of negative 2. 2 times negative 2 cubed minus 24 times negative 2. And if you put that in your calculator, you're going to get a positive 32. All right, now we have found the y values at our critical points. Now I also want to find them at my end point, so at negative 3 and at 4. The idea is whatever the biggest y value is going to be crowned absolute max. The smallest y value will be the absolute min. All right, so here we go. My parentheses got funky. I did this earlier, so this is a negative 18. Actually, I lied. It's a positive 18. I'm going to get a negative 54 plus 72. That's a positive 18. All right, excellent. All right, and last but not least, when I plug in 4, I'm going to get 2 times 4 cubed minus 24 times 4. All right, and this one is going to end up being a positive 32. A positive 32. Let me just double check that. This will be 64 times 2 is 128. Over here, 24 times 4 is a negative 96. So yes, it'll be a positive 32. Okay, so I want to look for the smallest y value and the biggest y value. So the smallest y value is this guy right here. So that's our absolute min. Okay, so we would say our absolute min is at the point 2, negative 32. Okay, now what's our biggest y value? We have a tie. In most books, if you have a tie, you don't have two winners. We say there is no absolute max. It's like there can be only one. Okay. However, we might want to write a note that, oh, by the way, we had a tie. But assuming that we want just one value, we would say no absolute max. But there is an absolute min at 2, negative 32. Now, the beautiful thing is that if you'd like to, you're welcome to graph this in a graphing calculator or Desmos on this interval, negative 3 to 4, and we should be getting the same thing. You will definitely have to play with your y values on your axes to make sure that you're seeing the whole big picture, but we should be able to see an absolute min and a tie for absolute max. All right, that's our first example of finding absolute extrema using a polynomial.